Here we have a case study made by two organizations, which are Binario Etico, which I represent, and Sensei, which is represented by Alessandro. And it is about making an application working on OpenStack, and in particular a Dockerized application working on COE on OpenStack. The agenda is a little bit introduction of our organizations and why we decided to join our efforts to make this. So what are our reasons to automate our infrastructure? We will show you the setting that we came up to, and this setting is using Kubernetes on OpenStack. So we will show you briefly how Kubernetes work on our setting, and we will leave space for the case study, for the demo itself, because that's the real object of this talk. So now a quick introduction. First, Sensei.
Hi everyone. So in Sensei, we do, of course, development for an enterprise environment. In our project, we promote Agile and DevOps practice. We have a partnership with WSO2, and recently we started a new partnership with Docker and experimented Docker for internal use. So we had a very good result in developer environment. So we decided to make a step forward to understand how to use all of this in production.
And about us, Binario Etico, we deal with infrastructure, so we are pretty complementary with Sensei. We are focused on OpenStack, and we offer infrastructures and support. And typically we work with companies that develop, like Sensei, and so we want to control and automate the infrastructure level, and in particular we want to provide support for orchestrating containers. So this marriage happened also because we both belong to Rete Italiana Open Source, which is a business network focusing on open source technologies. So one more reason to work together. And basically we started to collaborate to integrate the full stack from the source code down to the virtual machine. And Sensei provides Docker images, so arrives till the point of preparing the artifacts. Binario Etico provides the OpenStack infrastructure, and we meet in between on Kubernetes.
So what are our reasons from Sensei perspective? Well, for sure, change the development workflow so that we can create and deploy new artifacts, such as Docker images, to be uploaded into a private registry, so that developers can take these images and apply some configuration so that they can build additionally artifacts. In this way, the configuration management take part of the build. Artifact can be deployed, destroyed, and deployed again. In case of any configuration change, this process actually triggers the build of a new artifact. And a very good reason of everything is that in any Dockerized project, everything is under version control. And this basically enables build automation and source to image that in order to address your continuous integration requirement, but also continuous development and quality assurance task. One for all of this improve the collaboration across users, teams, and projects. And then you have full application lifecycle control from dev to production.
And as I said, from our perspective, we want to deploy customers' build artifacts, Docker images, so that having that running on Kubernetes and on OpenStack, we can control both horizontal and vertical scaling in very convenient way. We can monitor the single application components instead of monitoring one monolith application. And we gain in stability, and we can offer stability and availability to our customers. And possibly if the customer wants, we can use multi-cloud, hybrid clouds, multiple data centers, no problem. It's so no lock-in. So the infrastructure can be changed quite easily. Okay, so our setting, again, I said we met in Kubernetes in between. So what we've done is very, very easily. We created the virtual machines that were needed for the Kubernetes cluster to work. We configured the nodes of the cluster, and then we deployed the Docker images on top of Kubernetes. And using the power of Kubernetes, we can keep up with the production, which means that we have a single point of management. All metrics get real-time, central log aggregation, and in general, if you got a problem, you can fast react to problem. So Kubernetes, it's this distributed orchestration engine for containers, and it is made of pods. The pod is a set of containers that share a namespace. In our case, we have one container per pod in this use case. Pods are then scheduled to the actual nodes as a unit, and you have the concept of service, which is how pods can communicate between them on the same node and intranodes. That's the architecture of Kubernetes. And it is, very convenient to make replication, load balancing. It's all done via a very nice dashboard and shell. So let's go now to the case study itself. So before going through the details of the case study, I give you a very brief introduction about WSO2. WSO2 platform is based on Java, open source, mono-licensing. It's actually a suite of products to address different architectural requirements. Main areas that the platform covers are API management, integration, identity and access management, analytics, and IoT. So you can use one or more product. They can be installed on their own or integrated. They can be easily integrated. Also, you can install it on premises or use the public cloud of WSO2. We are going to use two distinct products in our case study. The first one is the Enterprise Service Bus that enables communication among various applications. So instead of having to make each of your applications communicate directly with each other, simply each of your applications communicate with a bus, and the bus which handles transforming and routing messages to the expected destination. So the Enterprise Service Bus supports enterprise integration partners as well. The second product is the Data Analytics Server that is in one solution. It's a one solution basically with the ability to build systems and application to collect data from different sources and analyze both real-time and persistent data. And the result of your analysis can be communicated externally in a variety of different interfaces. So going through the details of this case study, we're going to use Twitter as our data provider, and basically the ESB connect to Twitter through the streaming API. The ESB is responsible to download a stream of tweet and filter by the information we require and publish some event over TCP against the data analytics server. On the data analytics server side, those events are collected and we run some real-time analysis in order to spot some insights, some stats basically. And those stats are then communicated against the internal dashboard of the analytics server.
So from Kubernetes deployment perspective, well, okay, this is a cluster Kubernetes master, and we're gonna have one service and one pod for each, let's say, WSO2 product. For this case study, the tools, the application are supposed to be standalone. So in this way, the replica set will be just one. So regarding a demo, the application side tool review here. In this picture, you can see the deployment workflow. So basically, where is it? Okay. This is actually light blue boxes, okay, at the bottom. They are artifacts that WSO2 provide, except Oracle JDK, of course. These artifacts you can use as it is or customize according to your needs. So together, the application artifacts that is actually your business logic application, then you can build the Docker image. And this Docker image is basically uploaded to a private registry. And finally, you're going to run the deploy of the Kubernetes artifacts reading from the private registry.
About the infrastructure side tools that we use for the demo, basically we deployed Kubernetes on OpenStack using these 3 tools. Installing Kubernetes can be quite tough, quite hard. Lately, these tools arrived that make things a bit easier. So kubeadm, Ansible is used for the orchestration of the whole thing. So if you need to raise the nodes of the tenant, you use Ansible. If you need to configure the nodes, use Ansible, and then use WeaveNet to make containers communicate with one another. So there's a long procedure. We don't have time to show that. I mean, you configure and launch the master and the nodes. Then you set up the nodes using kubeadm, and then there are some add-ons that we wanted to add to Kubernetes to have, for example, the statistics of the load balance of the loads of the nodes, which are useful when you have to see if there are problems, and they can help us to verify that Kubernetes is doing its job, which is to balance the load among nodes. And finally, you need a local kubectl configuration within Kubernetes to set the proxy.
Okay, quick step back. In our demo, we bypass step 1 and step 2 because we don't have enough time to do it. So just deploy the Kubernetes artifact. So every Docker images is already there, so we don't need to build anything, okay? So live show. So what are you going to see in this demo? So basically I will deploy the Kubernetes artifacts, so the application. Then I will go through the analytics dashboard in order to make you able to see the different graphs that we have set up. And finally, we're going to produce some failures to the cluster so that we can see how the Kubernetes react and manage this strange situation. We're going to, let's say, simulate 2 kinds of failures. The first one is the drop a pod, and the second one is drop the whole node. So let's move to the dashboard. Okay, this is the Kubernetes dashboard that you may already know. So here we have the information about the cluster, namespace, and nodes. Regarding the nodes, we have 3 distinct nodes, OpenStack day 1, 2, and 3. The default namespace is the namespace that we use to deploy our application and our pod. And here you can see that we don't have anything deployed inside deployments and pod as well. In terms of configuration, we're going to have two distinct YAML files, one for the ESB and one for the DAS, to just deploy one service and deployment. So for instance, we have sorry. So in this case, we have the DAS. Here, there is the details of the service. And then we have the details about the deployment here, where there is the configuration about our replicas and the Docker images, and few other information like liveness prod and readiness prod. So I'm going to skip the second file because they are quite similar. So let's create our pods. First create the first pod about the DAS. So service and both service and deployment are created. Then the ESB. So as you can see, both pod looks are already running, but actually they are not ready yet. This means that the application didn't start completely, so it's still in the process to be completed. So the same state is available from the dashboard. So here we have deployments are ready, looks okay. Regarding the pod, the DAS pod looks okay, while the ESB is still in process to start. Then we are our services. Let's check. Okay, now they look both ready. But I skip one important note. So basically, if you want, if you have a Twitter account, you can take part of this demo directly. Sorry, you noted, yeah? So basically, what we are going to filter from the data stream from Twitter is basically tweet written in English using one or more of the following keywords. So you can tweet using one of those keyword, and then you can take part of the demo. So, okay, as you can see, the DAS has been assigned to OpenStack 1, and the ESB has been created to OpenStack day 3. So let's go. Let's log in into the dashboard. So basically, what you can see are 5 distinct graphs. At the bottom, you can see just basically the tweet stream. And the top, the popular hashtag in the last 5 minutes. Consider that according to this custom configuration, an hashtag is displayed in this graph if has been used at least 5 times in the last 5 minutes. On the right, you can see the tweet number in the last 10 seconds. And here in the middle, the sentiment analysis. The sentiment analysis refers to the process of determining. Can you hear me? Yeah. Refers to the process to determine whether a piece of writing is positive, negative, or neutral. And here we have on the right the same, basically another perspective of the same analysis, so the sentiment grouped by category. So I don't know if you are tweeting right now, but I can run.
There's a negative percentage, which is surprising. And the positive is so small. What did you guys? Are you saying something bad? Okay. We try now to tweet from here directly. Of course, we don't have many tweets, but we can maybe change the keywords and see some more serious stuff going on, maybe at the end of the demo.
Okay, I don't have connection to my mobile.
Okay, well, I mean, they have done it, so it's fair enough.
Okay, that's me, Alessandro Bevilini. Me again. Okay, so let's try something different. So we can produce some failure right now. So let's switch back to the dashboard of Kubernetes. And so let's try, for instance, to go to the pod and delete. So the previous pod is basically terminated, and the Kubernetes cluster already creating a new one. And this time, the new pod has been created to OpenStack day number 3. And this is completely automatic and decided by Kubernetes according to, I guess, the resource usage of the cluster in terms of CPU and memory. And probably in terms of network, I guess. So now, what we can try is to well, let's wait for the DAS, to be available again, and then we can try to drop the whole node. Okay, so I can give you the control. Just So.
Okay, the pod is up again, so we can show that it is still working.
Mm-hmm. You mean the analytics dashboard?
Yes, just analytics dashboard. So, yeah, okay, it is still working. Okay.
Okay, everything is up again, so we can switch.
So we failed the pod, and it was able to recover. Now let's fail the node. What is the node that we want to fail? Number 3?
Yeah. It's the only one that we can choose.
Okay. Okay, and you can just, go down here, OpenStack day 3. That's it. And we shut off the instance. And so the instance went down. It is in the process of going down, and in some seconds it will be shut off, and Kubernetes will realize that the node is down. Now, nodes. OpenStack day 3 is still there. Kubernetes needs some time to do this. And okay, now it's not there anymore. So what Kubernetes is doing now is to try to, migrate these pods on other nodes in order to have a good balance on the 2 remaining nodes. And it takes some time to do that. And after this time, node 1 and node 2, you see there. And once this is done, we will be able to show that the dashboard is still working. Okay.
Takes around 1 minute.
Okay, so maybe we can drive to, we can go to the lesson learned, and then we come back here when it is done. Yeah. So so we have seen how application development and IT infrastructure can collaborate within each other profitably, integrating the full stack from source code to virtual machines. And we have seen that thanks to Docker's containers, we can keep the application part completely decoupled from the infrastructure part. And this means that we can easily change the infrastructure part if we want, so not causing any lock-in to customers. We've seen that OpenStack proved excellent for Kubernetes orchestration, and this way we can have monitoring and management of a single application very neat and effective. So we are really at the end of the speech. Let's see if the nodes are recovered. Okay, now they are done, and the dashboard is still there. So another thing we can do is start the instance again, so that it will be part of the cluster again. And in the meanwhile, we can maybe show maybe different keywords. No,
I don't think we have enough time
yeah.
to do it.
Okay. Yeah, because we wanted to show some more interesting keywords like Donald Trump, which or maybe Bergoglio, I don't know. Okay, so this is pretty much all. Thank you.